face recognition using SVM and principal component analyzing. So simply we are going to detect and recognize these three gentlemen, uh, the ex-presidents of USA, right? Ex-presidents of USA, Barack Obama, Donald Trump, and George W. Bush, right? All right. Yeah. So we have a data set now. I selected these persons since I can find lots of pictures of this people, right? So that's why I use, right? I use this, right? And so the Barack Obama, the Donald Trump, and the George W. Bush, right? So we have a data set here like this, and we have some. Let me show you. We have some. Yeah. So in train data 2 folder, we have some data. We have some actually images. So we have 3 folders: Barack Obama, right? Donald Trump, and George W. Bush, right? I provided this to you, right? Isn't it? No, it's there. It is there, right? So this folder should be there, isn't it? I think it is there. I provided you this folder. So what about others? Is it there or not? It is, right? It is there. I upload the whole thing. This one. Yeah. So you have the test data and train data, these folders. So if you, I mean, simply what you have to do, I mean, you will be redirected to here. So you have to just download it. The whole folder will be downloaded, right? Got it? Okay. Yes. Okay. So the train data 2 folder, here you have some photos of Barack Obama. So this is simply downloaded from the internet, right? And Donald Trump, right? And the George W. Bush, right? So, okay, so the problem definition simply, when the image is provided, what we have to do, we have to identify whether this person is Barack Obama, Donald Trump, or George W. Bush. So can you define first whether it's a classification problem or regression problem? Quickly. Yes, quickly. Classification obvious, right? So how many labels are there? 3 labels, obvious. Okay, what would be the features? Features, labels are fine. Hair color, okay, obviously we can get the hair color. Yeah. Not exactly, but I mean, like, what are the features? Yes, it can be also that. Yes, features, right? Yeah. So this is the point that you want the proper understanding. So I will go through the this one and let you know, right? Yes, exactly, pixel values, right? Not this one, not this one, not this one. Yes, right. So this is the problem, and the features will be, right. So labels, you can see Barack Obama, Donald Trump, and George W. Bush, and the label, I mean, the features are simply, right. The features are simply the pixel, the face pixels, right. So this is, you can see a low resolution image of a face, but this is what we are going to see as a face, but actually computer sees it as set of numbers, right? So if you have gone through my OpenCV tutorial, so can you tell me in a grayscale image, what's the range of the pixel value? What's the range of the pixel value? Getting answers. Good. Let's see. 0255. Very good. So I can confirm that most of you have gone through the tutorial, right? Okay. So anyway, in a gray scale image, the pixels like they are between 0 and 255. So 0 represents black, 255 represents white, right? So that's something that you know, right? So if you take a single pixel, gray image represents 0 to 255. Now, what we are going to do, so we will take these pixels, each and every individual pixel as the features in our problem, right? So we have to select a common size for all the images like 50-50 or 100-100. Otherwise the features might be changed, right? Then hammer image එක එකම size එකට convert කරන්න වෙනවා, right? Like otherwise the number of features will be changed to the, according to the picture, according to the photo, right? So each photo we have to convert it to a common size. I will explain that things, right? So anyway, the features will be all the pixels and the labels will be 0, 1, 2, right? 0, 1, 2. And what we can do, we can train the support vector machine, right? But why I say like we are going to use a pipeline here is that actually what are the image sizes that we are going to get is 50 by 50 images, right? 50 by 50 images. So we don't apply it directly to the support vector machine, since 50 by 50 is like 2500 features, right? 2500 features. 50 by 50 image altogether, we have 2500 pixels, right? So we have 2500 pixels. So what happens is, when you're going to train it, actually support vector machine, though I said that the support vector machine is a very powerful and a very accurate and the best algorithm available for classification task, SVM is still not capable of handling this amount of large dimensional data sets, right? So single image, if you take a single image, we have 2500 features. So SVM actually, yeah, it is capable, but it won't be accurate. So 2500 features won't work with that kind of a thing, right? So in that case, what we have to do, right? So this is the issue with the machine learning algorithms, the common machine learning algorithms. It can't deal with high dimensional data. It can, but it fails at some point, right? Sometimes machine learning algorithms can't go beyond some kind of, a limit of features, right? Some number of features. Machine learning algorithms වල තියෙන ප්‍රශ්න එක තමයි ගොඩක් large dimensional data, ගොඩක් features තියෙන data එක deal කරන්න බෑ, right? But we have solutions for everything. We have solutions for every question in the world, right? So we are going to use a help of another algorithm called principal component analysis, or we call it PCA, principal component analysis, right? And principal component analysis, simply what it does, right? So 2500 features, we can use the principal component analysis and convert it to a less number of features. For example, 150 features. Now you may be wondering, okay, that means are we going to remove some number of pixels in this image? No. දැන් හිතනවා හරි. එහෙනම් 150 නේ, එහෙනම් 1350ක් අයින් කරනවා feature. So we are going to remove 2350 features and get 150. No. It's not done like that. But principal component, as the name suggests, it's going to identify the most principal component or most principal features of this images, right? So for example, this background is not required, right? This background is not required, right? So you doing some analysis like that. Anyway, the principal component analysis going to get the most fundamental and the most important and most principal set of features, right? And reduce the number of features. So this is called principal component analysis, comes under dimensional reduction algorithms. So it reduces the dimensions of a data set. It reduces number of features of a data set, right? So after that, 150 features we can get. This is not a fixed number, 150. So I checked and I selected this as the optimal value, 150. So when we discuss about principal component analysis in the the fifth day, I will go through everything, how principal component analysis works and how we can select the number of features. Now, don't think 150 is the best number of features. No, sometimes it can be 200, sometimes it can be 50 likewise. So we have a method of selecting the number of features, right? The number of features that we are going to reduce these features up to. The අඩු කරන features ගාන කීයද කියලා බලන්නත් අපිට methods තියෙනවා, right? The total variance, yes, we can measure the total variance and do that, but principal component, under principal component analysis theory I will discuss. But today what you have to get the idea about a principal component, what the idea that you have to get is principal component. Since the classic machine learning algorithms couldn't work with large dimension data, right? What it simply does, right? So it's going to fail with large dimension data. The accuracy is going to decrease, like we have lots of issues. So we are going to use another algorithm, the principal component analysis, which comes under dimension reduction algorithms, and dimension reduction algorithms comes under unsupervised machine learning, and we are going to discuss how it works and how to select the the number of features that we are going to reduce it up to. Those kind of things we will discuss it on the last day, but today we will use it, and we are using it to reduce the number of features. So what will happen? Simply we input the image, and it convert it to less features, and how these this remainder reduction, what are the features to be removed and what are the features to be kept, those things we will discuss on the fifth day. And what we are going to do after reducing it up to 150 features, we apply it to the SVM, the support vector machine. And the other thing is that when it comes to principal component analysis, one important thing here, that this 150 feature, the number of features that you can decide it, but it's according to some kind of a theory. So we will discuss how to select the number of features that you want, right, on Friday. But this 150 features, simply I took it by checking it. So I verified it, and I run this before, and I selected 150. So this is the optimal value, right? So that's why I select 150. Otherwise we have to run some code and decide it using some kind of a graph, right? Then we apply to support vector machine, right? So then we have another method, another important point I have to explain you, that if you go through the images, right? If you go through the images, right? So you can see that these images are simply containing the background as well, right? Not all the faces, right? So you can see, right? So the background is always there, right? So what we have to do, simply we have to first get the face cropped, right? In order to identify the person, right? We don't need the background, right? We need the face. So we have to have a method of detecting the face and cropping this face, right? So in that case, we use something called Haar cascade classifiers, right? Haar cascade classifiers. So let me quickly move to the window, right? So here we use Haar cascade classifiers. So actually all the images, what we have to do is we have to crop this face, and then only we are going to apply it to, then only we are going to train it, and then only we are going to test it as well, right? When we are going to test it for unseen images, what we will do, simply we get the image and crop it. We are going to segment the ROI region of interest. The face, we are going to crop it and apply it to the cascade classifier, then crop the face, and then only we are going to apply it to the pipeline, and we are going to get the prediction. Now, what do you mean by pipeline? So here we combine two algorithms together, right? So we have combined two algorithms together. So that's why it's called a pipeline, principal component analysis put together with support vector machine. So the algorithm is a combination here, right? So we have combined two algorithms, principal component and SVM. So when you have multiple algorithms combined together, that's called a pipeline, right? So that's why we call a pipeline here. Understood? Okay, so right. So we will go to the code and I will see how we can implement this one, right? Okay, right? So now you can see my code is here, right? So this is the code creating the data set. So this is the code that I'm using. Now train data 2, actually it has some images, and test data has some testing images, right? So train data, what we are going to do first, we are going to use the OS library and as well as the NumPy library, right? And we are going to provide the data path, uh, train data 2. So this is the folder name of the folder name where the images are saved, right? Where the images are saved. Then now this OS library, the operating system library, we can use it for lots of applications, right? Now we have provided the data path here. Now I want to get the folders inside that data path. Now this R is for the regular expression. Now when you are always, when you are using Python, and if you are giving a path, it can be absolute path or it can be a relative path. It's better if you can always put this R. So without any doubt, you can get these paths, work with paths when you add this R, right? Keep that thing in mind. Anyway, now os.list directory, right? Data path. So I'm going to apply this data path to list directory. So list directory, I'm going to get the folder name. So let me get it to something called labels, right? So let me show you the labels. So what this means, right? So it's simply, right? So OS module list directory method. So list directory method simply, when a path is given, it reads all the folders, files available in the list you have provided, and it take it to a list, right? All the folders, files in this directory, it's taken into a list, Python list. So you can see the folders are here as a list. Now, for example, let me provide another path like this one. Okay. So I'm going to provide another path in my computer, right? This one. So you can see now these are the files and folders available in this path. තේරෙනවද? දැන් මොකද්ද මේ list directory කියන එකෙන් කරන්න කියලා තේරෙනවද? අපි මෙතන මොකක් හරි path එකක් දුන්නාම ඒ path එක ඇතුලේ තියෙන folders, files name ඔක්කොම list එකකට ගන්නවා. Python list එකකට ගන්නවා. ඒක තමයි මෙතනට අවිලා තියෙන්නේ. පැහැදිලිද? Right? So very useful one. Now, what we are interested is with the train data. So it gives us the labels. So these are the labels of our problem, right? Barack Obama, Donald Trump, George W. Bush. Now, very important thing, the code that I'm going to implement today, right? I have done this, right? A dynamic program. What I mean, right? So if you want to add another label into this, let's say, right? Now, what I want to say you, okay, no need to do these things, right? You can simply do it like this as well. Right? You can define the labels like this simply, right? Don't worry about like OS, list directory, nothing, right? But what's the advantage of using that kind of a thing is when it comes to, let's say that you are going to add another category or another phase into this, right? You are going to add another phase into this. Now, today I'm going to do it for, the US presidents, but later you can do it for your family members, right? Your father, mother, brother, and sister, right? I don't have those kind of image sets. That's why I'm doing it for you, but doing this for this person, right? You can capture images of your family members and you can do the same thing, right? So you can apply something like a CCTV camera and get in the, right? So you can attach a camera near the door and identify who comes, right? Then you can do lots of things, right? So Abraham, Joe Biden, right? Okay, so let's say that you want to update this, okay, the new president, right? Then what happens? If you add some images to here, what happens is that if you implement the code like this, right, what happens is you have to okay, manually add it like this, right? But if you do it using this kind of a dynamic method, what happens? See, right? No need to write. You have to just run the code again. So it reads the folder and get it updated, right? Understood? So that's why these things are important. So the code that I'm going to implement here is a very dynamic. That means when you are going to modify this one, right, you have nothing to change. You have nothing to change in the code, right? Now, so if you are going to do this for your family members, what you have to do, remove these folders and just include the folders of folders with photos of your family members. That's all. Right? So that's what you call dynamic code. That's how you are going to learn to code. Otherwise, if you are making an update, if you always want to change the code, that's not the method. You have to always be dynamic, right? The code should be dynamic. No matter what the modification you are going to do, the data set and everything should be updated here, right? Okay, so now the labels or we can say the categories. Yeah, categories. Let's say I will do it at categories. No. It can be done as labels. Yeah, it can be done as labels. But I need the category. Category. What do you mean by category? Is simply like we can have to have number like 0 for Barack Obama, 1 for Donald Trump, 2 for George W. Bush, right? So what I'll do is np.range, no, np.range length of labels, right? So you have seen this in the tutorials, right? So what np arrange does, right? So 0, 1, and 2, right? So we are creating a list 0, 1, and 2, right? So then we want to create a dictionary like what Barack Obama is 0, like 1 is Donald Trump, 2 is George W. Bush, right? I'll show you where this is used, but I want to first I will first create that dictionary, category dict, simply using the zip method, the keys and values. So you know what are the keys and values, right? So I'm going to use the labels as keys and values are the categories. So we have covered this in our basic tutorials. I hope you can remember. Okay, so simply, now we have a dictionary. It says Barack Obama is 0, Donald Trump is 1, George W. Bush is 2, right? Understood. So now what we have to do, right? What we have to do is simply let me right. Yeah, so now what I'll do, now I will implement the code with you. So then, so I will implement the code with you. So I'm going to import the CV2 module, right? And then I'm going to go through each and every folder and read each and every image, right? So it can be done like this. I'm going to go through each and every folder for label in labels, right? So what this means, now you know what's labels. Label is these three. So this loop will run 3 times, right? This loop will run 3 times. Now, if you update it for 4, this loop will run 4 times. So that's why I call like dynamic code, right? So label in labels, print labels. So you can see now it goes through labels, right? Then I'm going to create the path like this, oath.path.join, right? The data path is this path, and I'm going to combine it with the label. So what this does, os.path.join. So it joins this data path and the label together, right? And it creates image path, right? Something called image path. So let me show you what this path simply refers to. Right. So you can see train data, Barack Obama. So this is a path, right? Folders or the path, right? So the path of those folders, right? Then I'm going to do what? Right? So the path is created. So now I'm going to get all the image names inside these paths, right? os.list directory, right? So first, this list, this directory, we are going to get the image names, right? See, so image path and image names both, let me print it, right? List directory, right? Okay, so train data Barack Obama. So that's the image path, the first image path. And these are the image names available inside that folder, right? The image names, right? So then here, train data Donald Trump. That's the second image path, and these are the image names available. It's available as a list. And the third one, that's the third one. Actually, we can't identify it like this, né? So I will print a separate kind of a thing for each iteration of the for loop, right? And yeah, so this is the Donald Trump and this is the George W. Bush photos, right? So now this loop will run through each and every folder and gets the image names of each and every folder. තේනවද? හැම folder එක through run වෙලා මොකද කරන්නේ? හැම folder එකේ තියෙන image names ටික ගන්නවා, right? So that's what it simply does. Okay, so hope you are familiar with what's happening here, right? So now I want to actually read each and every image here, right? So then I want to load the image, right? So I'm going to create the image names and I'm going to create the now this is one iteration, right? So this is one iteration. That means this is for Barack Obama, right? This is for Barack Obama, right? So this is the list. I mean, the image name is the list of the images, names, name list of the images inside the Barack Obama, right? So what I'll do, I'll go through each and every image name in image names, right? The main image name like a palani part, right? So for the first time, these image names are the the names of the images available inside the Barack Obama folder. Second time, it will be Donald Trump's image names. Third time, it will be, right, George W. Bush. And what I'm going to do here, I'm going to take, okay, so let's say Barack Obama. I'm going to take the Barack Obama images and I'm going to go through each and every image, right? Go through each and every image. So what happens simply here, so if you print those image names, right? So let me print the image path like this, then you will understand, right? So, okay, we have the separator. Yeah, so let me print the image path as well, right? Okay, so the Barack Obama, so we are printing each and every image name, right? Hammer fold එකේම each image name එක ගන්න අපි යනවා, right? Understood? So then thereafter then thereafter the first the Barack Obama, then the Donald Trump images, and thirdly the George W. Bush images, right? So what I want to do, I want to read these images, right? So I'm going to create the image path. Yeah, let me change this to images path and let me have it like image path here, image path. So individual path of each image. So os.path.join. So I'm going to yeah, combine image path with the image name. So I'm going to create the path, and you will understand what this image path simply refers to. Right, so you can see the path of each and every image, right? Right, so train data George W. Bush, right? Train data George W. Bush, likewise path of each and every image, right? So what I'm going to do now, okay, I have the image path of each one, so I'm going to load the real image using the OpenCV imread command, right? So I'm going to provide the image path here. Then let me show the images, cvd.imshow live and the image, right? And then let me provide the delay in between each and every image. cv2 dot, sorry, wait key. So you know what wait key, right? 100 millisecond delay. And if cv2 dot yeah, so let me have the key pressed here. So if the key is the escape key, so you know these things, I covered these things in that thing, right, the tutorial. If it is the escape key, I'm going to break it. And finally destroy all windows, right? So let's see whether it's going to so you can see now it loads each and every image, right? So it loads each and every image. Now the Donald Trump, right? And then you will see the George W. Bush, right? So likewise, now you can see the code that we implemented. Simply it goes through each and every folder and get the image path and get all the image names inside that folder. And we are going to go through each and every image name, and we are going to create the image path for the path of each and every image. And we apply that into the OpenCV imread function, and we read the image. Then we show the image here, and we wait for like 100 milliseconds for each and every image. And once the escape key is pressed, all the windows are destroyed, right? So that's what happens. Now the code that we implemented simply loads each and every image. Now we have to have another thing here, right? That I told you that we have to always crop the face and get it, right? We have to crop the face and get it, right? So in order to crop the face, we have to use something called cascade classifiers, right? Cascade classifiers. So what do you mean by this cascade classifier? Let me, I think we have some, um, um, yeah, I think it's here. I will provide you this tutorial as well, right? So anyway, what a cascade classifier simply do, right? So cascade classifier is, don't think that this is a very novel and a very new technology. No, it's not, right? So this is something invented in 2001, but a very useful and a very accurate method, right? So what we can do using Haar cascade classifiers, we can use Haar cascade classifiers for object detection. So before neural networks came into play and before everything uh, was there, right? So we use Haar cascade classifiers in the early days to detect objects, right? Now, the thing is, before you, I mean, the old phones or even had this feature, right? The face detection and everything, the object detection. So that's due to these Haar cascade classifiers. So what this Haar cascade classifier simply does, so Haar cascade classifiers, we have lots of Haar cascade classifiers, and they can be trained to detect only one object or one kind of one kind of object, right? So we can design a Haar cascade to detect face. We can detect another Haar cascade classifier to detect eyes. We can detect another Haar cascade classifier to detect uh, cars, another Haar cascade classifier to detect bikes, another Haar cascade classifier to detect Apple. Likewise, a single Haar cascade classifier can detect only a single object, right? So we have Haar cascade classifiers trained for face detection, right? The front face detection. So what we are doing is we are going to simply use that kind of a Haar cascade classifier in this application, and it simply uh, crop our face from a image given, and once a image, let's say a face, image with a face, we are going to apply it to a face detection Haar cascade classifier. What it simply does, it it detects the object there, the face, and it provides us this XYWH parameters, right? That means going to draw a rectangle or the crop the object, and it's going to provide the XY parameters. What do you mean by XY parameters? These parameters of this point, and the W and H, the W and H, right? The W and H values of the parameter, I mean the face, right? So it provides us the X and XY WH, right, of the detected object, right? So we simply use this Haar cascade classifier. So I'm not going to go through the Haar cascade classifier. So what I can do, I will provide you a full tutorial on this Haar cascade classifiers and object detection, but it's not a mandatory tutorial. But I will provide you as extra tutorial. What you can do, you can go through this object detection using Haar cascade tutorial when you have time, right? It's not a mandatory. I will provide you as extra tutorial so you can get a knowledge what happens in Haar cascade classifier. So full details about Haar cascade classifiers, right? But for now, what you need is Haar cascade classifiers. A single Haar cascade classifier is trained for detecting a single object, right? For let's example, face, bike, car, Apple, likewise. So what it simply does, when image is provided, let's say we have interested object, okay, we are going to have the Haar cascade classifier for face detection, let's say. So if you apply an image with the face, it detects XY and WH of that from that given image. So the cropped one, right? The X1 WH, the parameters of the face, right? It's going to segment it, right? It's going to segment it, and it provides us X, W, and X, Y, W, and H, right? Okay. Yes. Yeah. So what we'll do here, right? So in your working location, you have this Haar cascade classifier file, right? Haar cascade classifier file in your working location. This one, Haar cascade frontal face classifier. Right? So this is the Haar cascade classifier, and simply this is the cascade classifier that we are going to use for face detection. So it's a simple file, right? But if you want, like we have several other Haar cascade classifiers for face detection, bike detection, eyes detection, lots of, right? So when I'm going to provide that extra tutorial, not mandatory tutorial, You will get those files and you can detect other objects like bikes, cars. So those files also included in that tutorial, right? So you can have a look, but today only we have this face detection file here, right? So what I'm going to do, I can load it here using this command. Let me yeah, so let me get it from yeah, this is the code that you are going to use to load that classifier. There's a face classifier, and what we can do simply, we can add before doing that, these Cascade classifiers are working with gray images, right? Not for color images. Now the images that we have are color, so we use the convert color function, as you can remember in our tutorial. Convert color function, and we convert this image into a gray image. So it can be simply done using cvt dot convert color, and you have to provide the color flag bgr to gray. So if you are wondering what this code does, let me show you the color converted image. So using this command, we can convert the color image. So we are loading the color images and we can convert it to gray, right? So let me show you the gray image from here. Right, so bgr to, okay, cv2 dot color bgr to gray. So you can see it convert it to the color, right? Color image to gray. Sorry. Right. Sorry. Right. Okay. Yeah. So what I'll do now, we have like first converted to now. Is it important? The color feature, is it important to this application, the face recognition application? Color, is it an important factor? What do you think? For this kind of application, face recognition, is color important? What do you think? Huh? So we lose information here, right? When a color image is converted to gray, that means we lose some information. We miss the color feature, right? So is it okay? I mean, do we need color for to perform face recognition? What do you think? What do you think? Color is a important factor, is it? Um, okay. Yes, I think so. Yes. So you have idea like, okay. But if you take your family, let's say you are going to perform face recognition with your family members. I hope that all of your family members have the same skin color, right? So we can't differentiate it, right? Understood. So this application, the face recognition, no, color is not an important factor, since like some of they have the same skin color, right? So we can convert it to gray, and that's one factor. But if you want to use these Cascade classifiers, definitely we have to convert it to gray, since Cascade classifiers are trained for, most of them are trained for gray images, right? So you have to convert it to gray. And what you can simply do, you can detect faces in this detect multi-scale. Yeah. So from this classifier, the Cascade classifier, you can provide the gray images and detect the faces, right? So now if you are wondering what this phases, simply it's something like this now. Right, so when you have like let's say you have two phases in, now these Haar cascade classifiers are capable of detecting multiple objects in the same frame, right? So let's say that you have two phases in the image, the provided image, you have two phases like this and like this, right? Like this and like this. So right. So now let's say this is okay, this is x1 and this is y1 and this is w1 and this is h1, right? And this is, let's say this one, right? So this is x2 and this is y2 and this is w2 and this is h2, right? So let's say this is the gray image, right? So if this is the gray image, when you apply that gray image to detect multi-scale function, what this return simply says, it gives you something like this, a multi-dimensional array which has 4 columns, xy, wy, w1, h1, right? And x2, y2, w2 and h2, right? So this phases, whatever the given, will be multi-dimensional array. It has 4 rows constant, right? X, Y, W and H. And it has the columns are dependent on number of object detected. Make a detected objects gana columns value. Sorry, rows value, right? So the number of rows are dependent on the number of objects in the frame, right? So if there is 2 objects, so it gives you x1, w1, h1 and x2, w2, h2 and these things, right? So if you have 3 phases, it's going to provide another set of x, y, w, h. Understood? Okay. So that's what you call phases. So that's what you call phases, a multi-dimensional array. That's what you are going to get, right? So what I'm going to do here, I'm going to go through each and every phase for, so you know that it's going to provide as xywh. So I'm going to do it like this, xywh in phases. So I'm going to go through x and xywh parameters of each phase. And then I'm going to let us draw a rectangle around these phases, cv2.rectangle, right? Can you remember what are the parameters to be provided when you are drawing a rectangle in OpenCV? Yes. So we have to provide what's the image that you are going to draw the rectangle, right? Then you have to provide the parameters like this. Now these things I covered in the tutorials. Sometimes you may not familiar. I mean, you may not remember those things, right? So if you are going to draw a rectangle like this, what you have to provide is simply you have to provide x1, y1, and then this point x2, y2, right? Okay, so this is how we are going to draw a rectangle in OpenCV, right? And the phase parameters you are going to get are x, y, w, h, right? So can you tell me if you want to draw a rectangle around the face, right? So you have to provide 2 points like this, right? The point 1, right? So point 1 is the coordinates of this point, P1, and this point, P2, right? So you have to provide the points of P1 and P2 here, right? P1 and P2. So, okay, so can you provide me P1 and P2 in terms of X and Y here? So my question is, I want to draw a rectangle around the faces. So any idea? Okay, getting answers. Okay, point 1, how we can define point 1? Yes. Okay, getting answers, good. Yeah, P1 is very good. X1, I mean XY, right? And yeah, so P2 simply. Exactly, very good. X plus W, Y plus H, very good, right? Very good, right? So that's the point 2, right? So you can see in terms of x and wh, point 2 can be defined as, right, x plus w, y plus h. Then the color of the rectangle in terms of BGR, so BGR, so yellow color thing. Then the line thickness of line thickness in pixel, right? Okay, so let us right. So you can see it's detected, right? Most of the images it's detected. But you can see some unwanted things are also detected, right? Unwanted things are also detected. I mean, false positives are also there, right? Here, the the the, the, the other people are also there, right? So we can't have those things, right? So now what we have to do, we have to have a manual, right? Can you see? Some other people are there, some other, I mean, false positives are detected here, right? So what we have to do, we have to have a manual verification here, right? So we have like when you are creating the data set, you have to have a manual verification, right? Since other people are there, that's one point. And you can see uh, sometimes you can see that some other objects also detected as faces, right? So if you can't clearly see it, I can provide a larger delay, right? See, and let me only show you the the color one, not the gray one, right? See, some unwanted things are also detected. See the tie, right? Right, see, some false positives are also detected. So we have to have a manual verification method in order to overcome this issue, right? So what I'm going to do, right? So what I'm going to do is I'm going to do something like this, right? So I'm going to get, right? So what I'm going to do, no need to draw the rectangle, right? So that's only for your, right? I wanted to show you that the face is detected, but no need to draw the rectangle. What I'll do, I'll crop the face, right? So we can create the crop, we can crop the face like this, right? We can crop the face like this. The gray image, I'm going to get x to x plus, sorry, I think it's x or y. Yeah, first y to y plus h, and x to x plus w. So what I'm doing is I'm cropping the face, right? So I'm getting the area like what? Uh, right. So you know that this is x and this is y, and this is w, and this is h, right? So I'm from x to x plus w, y to y plus h. So I'm cropping the face and taking it here, right? So if you want to verify, I can show you that. Uh, right. So now the cropped faces are detected, right? Crop faces are here, right? Sometimes some false positives are there. Now only the crop faces are here. some false positives are here, right? Right. So tie detected, right? So the tie is detected. Likewise, we have some false positive as well. So we have to have a method of verifying. Now, what we are doing here, we are trying to create the data set. Right? So we are trying to create the data set. You know that the features are the images and the labels are simply whatever the 0, 1, 2, right? But when you are going to crop the face, you can see that some false positives are also detected. We have to have a manual verification method to do that, right? So what I'm doing here, right? Let me close this, right? And what I'm going to do here is once the image, once the face is cropped, I'm going to show it. Then I'm going to have a infinite delay, right? Infinite delay here, a infinite delay, right? So that means what? This is like what happens. So infinite delay. Once you press a key, then only it moves the next one, right? See? Understood. So see, once I press the key, only it moves to the next one, right? Okay. So then what happens here? Right. So what I'll do, that I'm asking like, okay, and I'm going to have two empty arrays like data and target. So data simply contains the image, right? So data will contain the image. Data will contain the image, and the target I'm going to append the label like 0, 1, and 2. So data I'm going to append the image, right? So if I'm going to wait for an key. If the key is if the key pressed key is 1 to 1. So what I mean by 1 to 1? You have to refer the ASCII value, right? So you know how the ASCII value and these. So if we have to refer the ASCII table, and you can see the ASCII value of 1 to 1 simply, yeah, Y. So if we press Y, that indicates that, okay, take this as a image, otherwise neglect it, right? So you can have something like this, right? So I can print something like this too, right? Okay, print like this, print if you accept this cropped face, press Y, right? So if you press Y, right, then what we can do, we can append the data, we can append the image to the cropped image, into data, but you have to convert it to a common size, right? You have to convert it to a common size, so we will use size 50 by 50, right? So what I'm doing is the crop face, I'm going to get the crop face, and I'm resizing it to 50 by 50, right? A common size. So all the images should be in common size, since otherwise they won't contain the same size of features, right? So we convert the image into 50 by 50, right? Then the crop face is appended to the data, and to the target, what we need to append, like 1, 2, or 3, right? Where that means whether it's a George W. Bush or a Donald Trump or a Barack Obama, right? So we apply the image, and with that we apply the label to the target, right? So what we can do, we have a dictionary called category dictionary, and from the category dictionary we can get the category and apply here, right? So category now, sorry, the label, right? Sorry, label, right? Yeah. So yeah. So what happens here simply, right? What happens here simply, that category dictionary, you know, Barack Obama 0, Donald Trump 1, George W. Bush 2, right? So we can keep a track what the person that, I mean, the image is correspond to which label, right? Why? Now we are first going to the Barack Obama. So then the label is Barack Obama. So that means if the label is Barack Obama, that label should be, I mean, the target should be 0, right? So we can keep a track of the person by referring the label, right? So we can use the category dictionary and assign the label. So it provides us whether 0, 1, or 2, right? So that's pretty much everything. And finally, what you can do, yes, that's pretty much everything. So you can run this, right? You can run this, but you have to involve manually here. You can press Y to accept, right? And accept. This not accept. So press any other key. Here, accept, right? So likewise, you have to manually do this, right? You have to manually do this for all the images. It takes time, right? It takes time. Right. So අනිත්ලාට එන්න බන්න එන්න එබුවා කියලා මුකුත් වෙන්නේ නැහැ. yes එබුවොත් විතරයි append වෙන්නේ. no එබුවොත් append වෙන්නේ නැහැ. Right. So if you press yes, why it adds to the data set, otherwise it won't add to the data set. Understood? Right. So that's what happens. So now you have to involve here, right? You have to involve here and do this manually and get whatever the interested images, right? So you have to spend some time here. Now what I'm expecting from you, you can do it and test, but finally what I have done is simply I have converted that data and target into set of numpy arrays, right? Set of numpy arrays. So finally we have 285 images, 2500. So I have flattened it as well. Flatten in the sense, now we have 50 by 50 images, so somehow we have to convert it to a flattened version. So what we'll do is we will convert it to 2500, like the flattened version. What do you mean I flatten? What they flatten karna කියන එකෙන් කරන්නේ? It's like this. Let me show you. Right, so this is what you call flattening, right? So the 1D, 2D image, you can flatten it to like, you can create a row vector, right? So each row is flattened up, right? So that's what you call a flattened image, right? So here what we are doing is we flatten it to a 2500. 50 by 50 was there, but we flatten each image to 2500. And then finally, that's it. So we have 285 images, and each image has 2500 features. So this simply says data shape is 285, 2500. That means we have 285 images of which each has 2500 features, right? So we can have a track about like how many images are there for each category. So Barack Obama 130, Donald Trump 91, and George W. Bush 81. Not a balanced one, but almost balanced, right? Okay. So this code that actually explains you how to create the data set. So simply what we did was we had some folders with raw images and we cropped the faces. Then we resized it to the same size and we did the manual verification, since sometimes it contains some other people's faces as well as some false positives. Tie is detected, some background is detected. So we did some false positive verification and also like manual verification. And thereafter we appended all the data into our data set, and finally we convert it to numpy arrays, and we flatten all the images into like one dimension like row vector. Then we save it finally as numpy files, right? So they save them into physical files called data and target, right? So you have the data and target here. So those arrays are saved here to data and target, right? So from here onwards, the next code simply explains how to let me go back. Right. The next code train the SVM. So this code, using that data set, we simply create the pipeline with the principal component and the support vector machine. We create a pipeline and we train it, right? And then we dump the question for your problem, how to save it to a physical file. So this is how we are going to save it to a physical file, the saved model. And finally, in this code, you apply some test images, right? You apply some test images and perform the right. So here you can see this is final result, right? So this simply the testing the SVM simply test it the saved model. So we load the saved model from here, right? And then we test it for some testing image. So it correctly identify Barack Obama, Donald Trump, George W. Bush, Donald Trump, likewise, right? Okay, so this is how we are going to do it now. But what I want from you, yes, I will upload the remaining tutorial, I mean the remaining two codes, explanation of remaining two codes as a tutorial. But we went through the most important part and the complex part, the dataset creation, right? So we go through the dataset creation. So I hope that you understood. What I want from you, please try to do this for your family members or your friends, or do and try to implement a face recognition for your, I mean, family or your friends, right? What you have to do, simply just the only thing that you have to change here, these folders, apply your own folders, and not necessarily be 3. You can apply in any number of things, right? Okay, so I will stop from here, but the important thing, keep this thing in your mind, right? So I went through the creating dataset code. So we have two other codes like the training and the testing, right? So how to train it and save the model into a physical file. And the last one is testing the support vector machine, how to test it for some unseen data. So those two explanation, I will upload it as a tutorial for today, right? Please go through. It will be like less than 1 hour, right? Most probably. So please go through that tutorial, right? And you know the theory about SVM. The remaining part like the remaining part in the sense like after the dataset creation, what to do, the training, how to train the SVM and how to test the SVM, those will be uploaded as a tutorial, right? So please view that before coming tomorrow, right? So tomorrow what we are going to do is we are going to move on to the regression problems, and tomorrow also a very interesting topic. We are going to discuss about theory part of the linear regression, and thereafter we are going to implement a web application using Python, very interesting web application using Python for heart risk level prediction of a patient, right? Okay, so since the time is already past, I will stop it from here. So before stopping, if you have any doubt, any concern, any errors of your code, anything to be clarified, you can ask now. Others, if you don't have any doubt or any issues, they can leave, right? If you have any issues, any doubts or anything to clarify, you can stay and ask. But one important thing, the remaining two codes, training the SVM, testing the SVM, will be uploaded as the tutorial, and it will be a very small tutorial. So the remaining part of this project. Okay, so any other doubts you may have? Yes. Okay, then seems everyone is fine with the content today. So let me stop it from here. So thank you very much. And we will meet on tomorrow and discuss about linear regression. Thank you and good night, everyone. right? So now we will go to the uh, code where we are going to support vector machine. We are going to train the support vector machine. So here we can, what we can do is first, right? First load the data set, import numpy as np and data equal np.load. So we can load that data.npy. And another important thing, now when you are saving the file, no need to give like data.npy and .target.npy when you are saving this one. It automatically adds the extension and save it. So don't worry, no need to give the .npy extension. It automatically adds the extension and save it. But when you are loading it, you have to give the extension. Okay, great. So now let's print the data.shape and also the target.shape. Okay. So you can see now what this means. This means like we have 285 images. After cropping, we have 285 images. So we can, right? We can see how many images are there for each label, right? So we can check how many images are there for the each label. From collections, print right? So it says like, okay, zero, I think zero is Barack Obama, 81 images. So one is Donald Trump, we have 130, and two is George W. Bush, so we have 90. So it's almost balanced, right? So almost balanced data set, right? Around 100 for each one, around 100 for each target. Okay. Okay, good. So now what we have to do is train the algorithm, right? We have trained the algorithm. Now, first we will display the data set, right? So from sklearn.model selection, import train test split, right? Train test split and train data, train target, test data, test target, train data, test data, and train target, test target, and train test split, data target, and we can use the test size of let's say 0.2, right? 0.2 or 0.1, anything. 0.2 would be fine, right? And then there's an important point that you need to understand here, right? That means we have to implement in this code a thing that we didn't discuss earlier. So now we have how many features here? You can see each image. Now we have like 285 images. All the images has, every image has 2,500 pixels, right? But the thing is, the machine learning algorithms, when it comes to machine learning algorithms, the machine learning algorithms cannot handle this amount of features, right? The machine learning algorithms cannot handle this amount of features. It's like, I mean, neural networks, totally fine. Neural networks can handle hundreds, thousands of features. It's fine. Even, yeah, a neural network can handle this kind of a thing. But when it comes to a machine learning algorithm, the one thing is that it can't handle this amount of data, like 2,500 features, right? So in that case, so if we apply this as it is, that means if we apply this 2,500 features as it is, right, as it is, what happens? That the machine learning algorithm will fail. That means it won't give that much of accuracy, that much of a result, right? That much of performance. It will fail. That means it will give a low accuracy, low performances. It will try to overfit or underfit, right? So what's the thing here is that we need to somehow find a way to reduce this number of features without reducing the information, right? That's how we are going to do it. I mean, without reducing the information, we have to reduce the features. We can't do that. I mean, if you like, okay, if you reduce the features into 150, let's say, right? If you reduce the features to 150, that means, okay, we have 2,500 features since we are using 50 by 50 image. So if we convert somehow, if we if we somehow convert it to 150 features, that means we have lost around how many? Like 2,350. We have lost 2,350, right? So we are going to definitely lose information. But we have a method called principal component analysis, right? Principal component analysis, and it will help us to reduce features without losing that much information. Definitely information will be lost since we are reducing features in the sense, right? That means we are reducing information from the image. But the thing is, principal component analysis, we have algorithm. Now this principal component analysis categorized under unsupervised learning, unsupervised learning algorithm. Principal component analysis is unsupervised learning algorithm. So what it can do, it can reduce the information, reduce the features, not the information, reduce the features into a given number of, into a required number of features. So we can provide, okay, we can ask the principal component analysis to reduce this to 150 features. Yes, we can do that. But the thing is, the principal component analysis is going to do it with the minimum information loss. It's going to assure that definitely information will be lost, but minimum information loss is going to convert the features into 150. So don't think that the principal component analysis is going to do it like this. Okay, we have 2,500 features. We are going to convert it to 150 features. 2,500. We are going to convert it to 150 features. Don't think we are going to remove 2350 pixels and get 100. No, it's not done like that, right? The thing is, now from this 2500 features, it's going to create new 150 features combining all the 250 features. So it's going to take all the 250 features and it's going to like do analysis. What are the most important features? What are the less important features? For example, now you can always identify that, okay, so if you take an image, right? So I will show you some cropped images, right? Some cropped images, right? So you can see now, we can always see that, right? So, right? So if we take this cropped image, so you can see now these set of pixels are not needed, right? These pixels, right? Not required, right? So likewise, it's going to analyze the most important features. I mean, the most important features will be here, right? So this area is very rich from the features, right? So the principal component analysis, as I mentioned earlier, don't think that it's going to remove, okay, let's say if we are going to ask, okay, now convert the 2500 features into 150 features, it's not going to remove 2350 features and give you the remaining 150. No, it's not done like that. It's going to get all the 2500 features and analyze them and get the most important features and somehow get 150 which with minimum information loss, right? So that's how we are going to do this. The requirement of using principal component analysis that the machine learning algorithms will fail with large dimensional data, large feature data set with large features, right? Okay, so I'm not going to go through into the working principle of the principal component analysis since it would take 2 hours to explain it. But I will explain how to use it so you can use it in your applications thereafter, right? So you can, at the leisure time, you can read about the principal component analysis. So here we are using the support vector machine. So let me first get the support vector machine. From the support vector machine, we are going to get the support vector classifier. I think you can remember that the support vector machine can be used for both regression and classification tasks. So we are getting the support vector classifier. That means the support vector machine version for the classification tasks, right? So then we have to get the, give me a second, I will come back. Okay, so sorry for the interrupt. Now, then we are going to import the principal component analysis algorithm. So it's in the decomposition, scalar.decomposition precision, import principal component analysis, PCA. Then now here we need to create a pipeline. That means it's like this. So we have this, right? So this is what you call a pipeline. So this whole thing is referred the pipeline. So what happens, right? What happens here? This is how the pipeline creates. So first we are passing a 50 by 50 image, right? 50 by 50 image. And that will be passed here to the pipeline, right? That will be passed to the pipeline. And here we have the principal component analysis. Actually, the thing is now we are not passing it like this, sorry. We don't have a 50 by 50 image. We have a 2500, right? We have a, right? So 2500 features. Right? And the principal component analysis is going to convert it to a lower dimension, right? Now here I have tested. Now the thing is we can't exactly say what number of features needed, right? What number of features needed. So what we have to do is we have to first analyze it, right? We have to first analyze it. So I will explain how to analyze it. But for now, let's say, I mean, we can't exactly say, okay, convert 2500 into 150, but I have tested this and 150 works well, right? Okay. Lecture is 9 a.m. in the morning at. Okay, Amo, sorry about the issue. Now I have informed it last time, right? But anyway, sorry for the. Okay, so you got the message later, right? So sorry about that. The thing is now you can get the recorded lecture, right? So please get the recorded lecture. So anyway, from today onwards, we are going to convert the, we are going to conduct the lectures in the morning, since due to the internet issue, right? So 9 a.m. and sorry about the delay. I mean, sorry about the thing is I informed that to the coordinator that the lecture is done on 9 a.m. today in the, I mean, yesterday I informed it, but sorry. So one of the participants have got the message at 3 a.m. So sorry about that. I will inform the coordinator to convey the messages early. And the other thing is that from today onwards, we are going to conduct the lectures in 9 a.m. right? And please stick that timetable, right? And if you have missed anything, please go through the recorded video. It will be you will be received it today itself. The recorded video of this lecture will be received to you. Okay, right? So okay, fine, it's fine. Now some of them are asking whether we can start at 10. Yes, it's fine for me, right? Fine for me. So I'll discuss with the coordinator and let you know, right? Okay, so 2500, right? 2500. So we can convert it to 150 features, and then only we are going to apply it to the support vector machine, right? Then only we are going to apply it to the support vector machine, right? Yes, right. So this is called a pipeline. So we have to create this kind of a pipeline. So there is a specific object to take, pipeline, import the function to make the pipeline. Okay, so first we will create the principal component analysis object. The principal component analysis object. So we have to pass how many components we required. So for now, I have tested it with 150, so it's working fine. So I'm using 150, but I will let you know how to decide this number of features. I will let you know in a minute. But here I'm applying a decided, already tested number, right? I will explain you how to test this, how to select the number of features required. So then whiten true, I will explain these parameters, random state 42. I will explain about the principal component analysis. This is how the object is created. And then we have to create the support vector machine object. So it's we created like this SVC, and we have to provide, not kernel is required, I think. Anyway, then I'm going to create the pipeline. So like this, we are going to create the pipeline with the PCA and the SVA. Support vector classifier. Right, so this is how the pipeline is created. But before going on to that, let me show you, give me a second to get the code. I think it's week 6. Right, so I will how to decide okay. So I'm going to import implement a code here. So this code can be used to decide how many features required, right? So right. So first we can get the principal component analysis. So now this section is not right. So please note that this section is not a code of this. Not important to our code, but this is how you are going to design. Okay, how many minimum components that I can use here? 150, 120, or 200. What's the number of features that I need to use here? The thing is, the objective is that we need to reduce it to less features as possible, right? Less features as possible. So that's the objective, right? But the thing is, now we can't convert it to 4 features. We can't convert it to 10 features without losing that much information. So in order to decide the optimal one, that means the minimum number of features we can achieve with the minimum loss, right? So that can be decided by this code. First, you have to feed the data into the principal component analysis algorithm. Then you can plot this graph. This is cumulative variance versus the number of components, right? I will first run this and show you, right? So you can see, right? So now this is very important graph. I will, so no matter what's the problem, you can use this code segment to, in order to identify how many features that you can use, right? So it's like this now. This is the cumulative variance. I'm not going to go through the in detail information, right? So these are the number of components, right? The number of components available. So what it says, right? What this says is that right? So you can see now if you have 250 features, the cumulative variance is almost 100, right? So 150, it's almost like 97. For 100, it is 90%, right? So I'm not going to go through the in detail terms, but in a high level, we can understand this cumulative variance as this. Okay, so if you reduce it to 250 features, the information will be like 100% information will be there, right? If you reduce this to 150, 3% of information will be lost, like 90%, 95% information will be there. So if you reduce it to like 100 features, then 90%, 10% might get lost, but 90% information will be there likewise, right? So you can see if you convert it to like 25, you will get to 80%. That means 20% information will be lost, right? So here, what I can see is that it's fair to use like 150, right? So since we have almost like 97 around, 97, 95. So that's why I'm using 150. And also you can measure the accuracy as well. So if you are not getting that much accuracy for 150, so you have to increase it to 200 features, right? Likewise, you have to do it. So this graph is important. This gives you understanding how many features needed to be used. So here, what we are doing, we have created a pipeline. When 2,500 features are given, we are converting it to 150 using principal component analysis. Then only we are applying the support vector machine, right? Okay, so what we can do here, we can then components. Right, so the pipeline is created. So what we can do is, now we have to train it, model.fit, train data, and train target. Okay, so we have trained it. Now what we need to do is that we need to get some predicted targets and measure the accuracy. So we have done this right earlier, model.predict. And then from sklearn.metrics import accuracy score. Then the accuracy we can measure. The test target and the predicted target. So we are getting 73% accuracy. I'm not sure what's the reason, but we will use a different kernel. Okay. What was this now? I got good accuracy last time. Yeah, let me go through the code again. Yeah, now I'm getting 94% accuracy. Right. 94% accuracy. Yes, I think it's good. Shall we reduce the testing size to 10% and see? Oh yes, this is also fine. But shall we reduce the test size into 10% and see? So it has more training data. It has more training data. No difference, right? Okay. So we'll run it again. Okay. Okay. Now here we are getting, when we are going to run it, we are getting 96% accuracy. So we will go with this, right? 96% accuracy we are getting. So we will go with this model, right? Okay. So right. So I need to introduce you that the accuracy is not only accuracy is not the only method of measuring the performance of a machine learning model. We have some other parameters: precision recall, F1 support. Sorry, precision recall and F1. So those are also important parameters. So what we can do is we can get these parameters, sklearn.metrics, import classification report, and same as this, we can provide it test target, and also then we can provide the target names here, right? So target names, I can get it from here. Right? So this is a measurement. That means it says, okay, so this is what it says. So in the testing data, that means here in the model.predict, the test data contains 11 Barack Obama photos, 25 Donald Trump photos, 21 George W. Bush photos, and total is 57, right? And here this gives the precision recall F1 score, right, for each and every target, and here it gives the average, the total precision recall and the F1 score. So what I mean by precision recall and F1 score, I'm not going to explain them now. You can refer their definitions, right? So here you can see precision is true positives divided by true positives plus false positives, right? Recall is true positive divided by true positive plus false negative, and F1 is 2 into precision recall plus precision plus recall, right? Accuracy, so you can can't I directly get it here? Right. So this is what it means, right? The precision, recall, F1, and accuracy, right? So you can read about these things and get the idea. So this is important if you are creating a thesis, if you are writing a thesis, or if you are writing a report, then the accuracy won't be enough, right? Only the accuracy won't be enough. You have to, if it is a classification problem, you have to provide the precision, recall, F1 scores as well, right? So I'm not going to explain what precision, recall, F1, but they are metrics in order to, metrics that we can measure the performance of the model. So these are the definitions, so you can read about them more and get the idea. So finally, I'm going to get the joblib module and save the model. So now this is important. Now you have to check whether that all the all the targets are giving the same kind of accuracy. Otherwise, now let's assume now this average, this accuracy is the total average, right? But if you have to check whether the predictions are given for all the targets, right? So let's say now George W. Bush is like 50%, but still the total can be around 80. Understood? So that means one target is overfitted. So you are called it overfitted. Now there's an important point. Can you see that the Donald Trump is giving 100 means 100% accuracy? Can you remember that Donald Trump is like having more data, more images? So this can be an issue, right? So if you can get the, balanced data set, sometimes this will, all of them will be 100% accuracy. So Barack Obama is the least images, right? Barack Obama has least images, 81. So label 0 as 81. So that's why I think sometimes it can be an issue. The number of images we are going to use can be an issue. So what you can do is, you can make it a balanced data set, and sometimes it will increase the accuracy. And this is very important. Now, what I say is, here you can see this has 11, this has 25, this has 21 in the testing data, right? So what happens, for example, I will say something like this. So, okay, label 0, you are getting 30% accuracy, right? And you have, for the testing, let's say that you have 10 images, right? And for the label, this is example, right? So let's say label 1, you have 80% accuracy, and you have 50% accuracy, and you have around, let's say, 20 images. And for label 3, you have 90% accuracy, right? And you have, like, let's say 70 images. So altogether 100 images are there, right? So the average accuracy Average accuracy would be what? Huh? Yes. Average accuracy will be what? Huh? 30 into, right? So can you configure the average accuracy? 30 into 10 plus 50 into 20 plus 90 into 70 divided by 100. Since altogether we have 100 images, like 30 and 30, 70, 100, right? So how much this would be? 76, right? So that means we are getting 76 accuracy. I mean, this is example. Now, can you see that the label 3, since it has 90% and it has 70 images for testing, so it gives 90 accuracy. So altogether, if we average these labels, you get 76 accuracy. But this is not a good model. Why? The label 1 and label 0 are not giving good results. But label 3 gives good results, but it has 70 testing images. So that's a high weight, right? A higher weight, the highest weight here. So in that case, the average will be 76. So you have to always see this classification report in order to get the idea. If at least one, I mean, if one label is not giving like a good accuracy, then your model is not a good model, right? Just so you have to always, the accuracy is not the sufficient measurement. You have to always get this classification report and see whether all the parameters are at least giving 90, more than 90 or 85% value, right? So job leap, I'm going to save it. The model will be saved as SVM for face recognition. .sav, right? Save it. Again, the same issue, dump. Right? So now our model is saved here, called SVM face recognition. So now, so any questions you have before going on to the other code? Please ask if you have any question. What was the random state in PCA? Okay, now in the I will explain these parameters, not today, since I have to go through the whole principal component analysis algorithm, right? So I will explain this in a coming day when you are using like unsupervised machine learning. I will explain the parameters that passed for the principal component analysis. Okay, so we have another issue. I'm stuck at a point. Code is not working. Where? Can you show me, Risha? Can you drop me a screenshot of the error you are getting? Okay. Okay, right. So now, shall we go to the, if you have any questions, please ask. Right? So meanwhile, I will go to the third code where we are going to test it using some sample data. So testing the model, right? So now we have some sample images in the test images folder. sorry, test data folder. So now what we are going to do, we are going to apply these images and see whether we are getting a correct prediction, right? We have some sample images and we are going to apply these images into our algorithm and get the predictions. So first what we have to do is Rishabh, you can send me the image. So I will, until you send, I will explain the code, right? Okay, so testing the model. So I'm going to load the model first. Jobdip.load. And I will declare a category dictionary here, but the category dictionary now will be the other way around. I'm going to change the labels and the keys and the labels. 0. I will explain why I'm doing this. Okay, so then test data path. Test data path is test data. So Rishabh, are you getting any error here? Okay, so are you getting any error? The thing is now you have to remove that im show, right? Remove that im show part. No. So you haven't include this wait key. That's the case. Right. You haven't include this wait key. You have, right? You have it. Sorry, you have it. So what's the output when you are running the code? Okay. Right. So can you try by going to the kernel and restart and run all? Okay. So go to the kernel and restart and run all. Then it would be fine. Okay. So I have tried and see whether it's working. Okay. So I have declared the test path. And here I'm going to get the test image names. Test image names by os.list directory. Test data path. And you can check whether all the images are here. Right. So let us, probably we have to import the OS library. Right, so we have the testing images here. So we can go through each and every image now. for test image in test image names. So I'm going to like get the image path os dot path dot join test image path and test image. So I'm creating the path and thereafter loading the image cv2 dot imread. So the image is loaded here. So load image one by one. Then let's say test image, right? So thereafter what I can do, so now the important thing that whatever the things you have done, the pre-processing steps that you have followed for the training images or the training data, you have to do the same things, right? All the pre-processing things can be done. All the pre-processing steps should be done for the testing images as well. So everything needed to be done for the testing image. Otherwise, the model won't give the result, right? So you have to do everything that you have did for the training images. You have to do it for the testing images as well. So load the image, then convert it to gray as we did for the testing images, sorry, training images. So we have to apply it here and give the color conversion. Sorry, color BGR to gray. Okay, right. So then, right. So thereafter, what we can do is we have to get that face cropping thing here as well. Right. So then the prediction, so I will get this whole one. Right. So here now what we do, convert the image into gray, apply it to the classifier and get the faces and go through each face and get the crop face, right? Once the crop face is taken here, what we have to do? Yes, we have to resize it first, right? 50 by 50 now. We have different sizes, so we have to get it to the common size first. The crop face will be taken into 50 by 50, right? And thereafter what we have to do is we have to reshape it, right? Reshape it to 1 into 2500, right? 1 into 2500, flatten it. So that's it. And what we can do is then we can apply it to the model and get the prediction. So we are applying the crop face here and the result is taken. Now here you know that the result is coming in a one-dimensional array. So I'm getting the value to this one. It's coming as a one-dimension, I mean it's coming like this. So I'm going to take the value by taking the 0 index. So the value will be taken here. Then, I mean, it's coming like 0, 1, 2, not George W. Bush, Barack Obama, Donald Trump. It's given like 0, 1, 2. But what we need is the name, right? Barack Obama, Donald Trump. So we can use this category dictionary. So we can get the name from the category dictionary and we have to pass, what we have to pass is the result 0 1 2. 1 0 1 2 is given, we are getting the name from the category dictionary, right? So that's all. And what we do now, let us put a text and let us crop the face and show it, right? So cv2.rectangle image and sorry, not XIWH. So we did this last time, right? So you know what XYWH is. And thereafter, simply we have to provide the color. So I will use the green color here, BGR. So the green color. And thereafter, the thickness of the rectangle, line thickness from pixels. So I'm going to use 2 pixel wide rectangle. Thereafter, let us put a text. Put text. Image, I'm going to, sorry, not the image, it is test image, right? And so I'm going to put the name. So Donald Trump, Barack Obama, George W. Bush. So then you have to provide the location where this text should be placed, right? So where this text should be placed. Now, if you detect the face like this, right? If you detect the face like this, so then what you have to do is, okay, so you have to get, right, I'm going to put the text somewhere here, right? So how we can do it, I'm going to take the x parameter, x and bit in the top, right? Give me a second. Right. Yes. So I'm going to like, okay, so this is x. This is x and y, right? So I'm going to go up for like 10 pixels and place the text y minus 10, right? And then thereafter you have to give the font. What's the font we are using? So cv2 dot font. We have several font types available for here, and this is the font, and this is the font scale. So the in OpenCV you have to provide the font scale, not the font size. What do you mean by the font scale? So the default font scale is 1. So if you put 1.5, that means 1.5 times larger than that. So if you put 2 times larger than that. If you put 0.5, that means half times larger than the default font size. So the default font size will be 1, right? So you have to give it as a font scale. Then the color of the font, and then the font thickness. So that's pretty much everything, and we have to then show the image. So I'm showing the test image here, and So wait key, I'm waiting for 1000, and if escape is pressed, so 27 is the ASCII value of the escape key, I'm going to break it, and thereafter destroy all the windows. ev2 dot destroy all windows. Right. So that's it. Right. Right. So it's working fine, right? There is a small issue. Other than that, works fine, right? So now what I'm expecting from you is to do this for your own data set. Like you can get your family members, let's say 3 or 4 family members, and include images like 100 images of each, right? And do the same thing. You have to just change these things, right? You have to just change these names, and that's all the modification you need to do. Otherwise, the same thing. You have to include the everything in the train data folder, like creating this kind of folders. Inside the folders, you have to do it, right? And when you are testing, if you want to do it for the live video, what you have to do using a webcam, you can do it, right? So if you are using webcam and if you want to test the live video and recognize it, these are the modification you need to do, right? So I'm going to create a video capture. So it could be done like cv2.video capture. So 0 is basically refers to your default camera, right? Default webcam. If you have USB cam separately attached USB cam, right? You have to provide one. And if you want to like load the video file, then you have to give the video file path. Right? So that means if you want to load the video from your computer, just give the video file name here, right? Give 0 for your load your camera in your laptop, the default camera in your laptop, right? Then what you have to do is just comment these lines, right? And ret image, sorry. Right. So carefully listen now. These are the modification that you need to do if you are doing it for the webcam, live video. Another important thing, now don't give like 1 millisecond delay, sorry, 1 second delay. So reduce it to up to like 100 millisecond or 1 millisecond. Otherwise you are going to see like right lagging images, like since every frame is shown with at every 1 second, right? So these are the modification. At this line, comment out these lines at this line and change it here. That's all, right? So now it will work for the live video of your camera recorded from your, and the video captured from your camera, the web camera. So if you have any USB cam, you can use 1, 2, If you have two USB cameras, you can use one, the other camera two. And if you have a video file in your computer, you can load it like this, right? And other than that, if you have a Wi-Fi camera, you can put the IP address here, right? You can put the IP address if you have a Wi-Fi camera, right? You have to put the IP address and as well as the passwords and the username of the Wi-Fi camera. So you have to provide them, right? So okay, good. So that's pretty much everything, right? So please, as I mentioned earlier, please do this for your own data set, right? And see what are the results that you are getting.